this session, it's my great pleasure to welcome, firstly, to the stage, Masaaki Kosugi, the Vice General Manager of the Cloud Engineering section for Rakuten. Please give Masaaki a big round of applause, please, ladies and gents. And the SVP and Global Head of Sales for Rakuten Cloud and MD for the Middle East and Africa, Vivek Chadha. Thank you very much.
Okay, good afternoon, everyone. Thank you for visiting the Rakuten booth and taking your time for this presentation. We really appreciate your interest in our initiatives. So I'm Masaaki Kosugi, from responsible for cloud engineering at Rakuten Mobile. So first of all, let me introduce Rakuten Mobile. So Rakuten Mobile is the fourth mobile network operator in Japan. In just 2 years, we launched our mobile network services. So in addition, Rakuten Mobile is the first company we launched fully virtualized cloud-native mobile network. This achievement has created new opportunities in telco industries. Now, I'd like to talk about the main topic of this presentation, supported by the Japanese government. So this project allows us to accelerate our development of Rakuten Mobile and Rakuten Symphony technologies. So this project has 3 themes. First one is Edge Data Fabric functionality enhancement. So this is focusing on improving the collaboration between edge clouds and central data center to make storage more flexible. The second one is edge platform optimization. The resources in edge cloud is sometimes limited with few servers. So we are developing some of the features to use those resources effectively. The third theme is the integrated operation of virtualized platform R&D. This is aiming that now our industry is moving from the virtualized network function to a containerized network function. We are creating the management for both virtualized application and containerized application. This feature allows MNO to reduce the operational cost. Yes. Now I'd like to hand it back to my colleague Vivek. So he will introduce an innovation energy saving solution. We already tested this solution in the environment where we reproduced the production environment, and its effectiveness has already proven. So that is from my side. Over to Vivek.
Thank you, Kosugi. Hello, everybody. Good morning, and I hope you've had a great start to MWC 2025. Thank you for taking the time to come listen to some of what we are doing at Rakuten. My name is Vivek. I run the global cloud business at Rakuten Symphony for the telco segment. I'm just going to talk a little bit about what we have been able to already deliver in terms of innovations using the cloud platform across the network in terms of real-world energy savings. We're very grateful to some of the support from our subsidy team, Kosugi-san, etc., and the Japanese government in helping us accelerate some of what we've already been developing and delivering. But I'd like to first start with just taking the audience through an overview of what we learned when we started looking at historic data within the networks in where some of the highest consumption of energy is happening and where we thought it would probably make a difference in terms of ROI if we started doing some specific kinds of implementations of energy savings. So just in terms of any representative mobile network, the 3 areas which are marked in red, which is the base stations, the near edge, and the central data centers, for 2 very different reasons, these are prime candidates to do compute level energy savings. And the reasons are, if you are somewhere at a central data center, you're usually always running your compute very, very hot at very high utilization. And there is an opportunity to do something there. Whereas if you're at the far edge, there is a lot of spiky and burst traffic, and sometimes the patterns change as well. So if you're leaving a lot of equipment idle, that is another opportunity that we thought is probably worth exploring. And obviously the fan out happens massively more as you go out from the central data center towards the edge. What we've done within Rakuten, and this is, I am now talking on behalf of Rakuten Mobile just for the next few seconds. By no means is all of this delivered by the specific innovations I'm going to talk about in a minute. There's 4 different areas the Rakuten Mobile team has pushed and pulled the Symphony different sort of solution components to provide innovations. So the first is around RAN solutions, where our RAN teams are doing AI and machine learning algorithms to adjust what's happening in terms of power consumption on the base stations. And that's actually proving itself to deliver quite an interesting pattern of savings as well. I'm actually going to talk more about what we've done at the cloud and data center environment, where we are using deep learning based sleep modes and intelligently switching between C states, and in the coming quarters we'll actually attack P states as well. The key thing to note is we're doing this without impacting workload performance. Then there's transport level energy savings, which are happening from another part of the different teams. And last but not the least, we're trying to do certain changes with the RAN team and the OSS team on rig-based implementations, which can also lead to energy savings. What we've seen as a collective assessment so far across these various 4 topology changes that we are likely to put into the network starting 2025 is almost a 20% saving in the pre-production environment. This is an aggregate across the representative sample network. But if, and we will start implementing some of this into the production network at Rakuten Mobile in a very phased manner. But if I take you now through what we've specifically done in the cloud platform. So observability typically has had, from a legacy environment point of view, 4 parameters, right? So the world's been very familiar with alerts, metrics, events, and logs. There is a 5th parameter to observability, which is critical if we are going to talk about energy savings in a measurable and a manageable manner, and that is energy. So that's the 5th dimension that has to become part of everyday vocabulary for any CXO if they're actually going to track energy savings, energy consumptions. And they have to be able to report it consistently over time. What we've done is we have created power tuning and resource profiles within the cloud native platform based on a deep understanding of how some of the workloads place demand and how they perform under real world load patterns. And we are intelligently, without human intervention, based on algorithms, able to start switching C states from C0 down to C6 in a way that does not impact real-world network performance. And this has been tested extensively in a pre-production environment with rolling samples taken over several hours, over the estate running for several weeks, as many as 7,000 plus samples for every single test run, so that we don't have outliers. Very pleased to perform that, very pleased to announce that what we are seeing is almost 4% energy saving on every active node, about 35% energy saving on other nodes. These are cloud nodes. Across the cluster, if you look at an aggregate cloud cluster that could be running multiple kinds of workloads, there's about 25% energy saving. And now that's a significant number, even if you don't worry about the outliers. Even if you're in the ballpark of 15 to 20%, on an annualized basis, that is a significant amount of saving for a network operator. But the 2 most important things, this is happening with no drop in performance for the real world workload. And I'll show you a chart subsequently that shows you an actual plot of what we did with energy savings turned off and energy savings turned on for a real world workload. And the other most important part, when we tested this for our RAN workloads, we did not make a single change to the CU/DU, which means that once our Open RAN colleagues do additional optimizations to the CU and DU workloads, you will see an even additional boost in energy savings. So this is quite an interesting start that we've already had to seeing what are the real world benefits to energy savings. You can see a little bit of a comparison about the kilowatt hour usage before and after energy saving was turned on. And the graph that you see here is a 5G download test that we ran with 3 attached UAs for several hours over several weeks. We took about 7,600 samples, so roughly every 500 milliseconds we sampled it. And as you can see, the blue graph is without the energy savings turned on, and the orange graph is with the energy saving turned on. So to the end user, the difference is imperceptible. They cannot make out any change whatsoever in their user experience. So this is an initial step we are taking, and we are fairly confident that as we move forward and we start implementing some deep learning algorithms which not only base the logic and algorithms on past data, but think of the network as a living and an evolving thing, which changes over time with users, traffic, seasons, events. So what we are aiming to do is implement deep learning algorithms which learn the network's DNA over time and adapt when and where to change things. At a later point today, our BU president from Cloud, Partha, is going to talk a little bit more about some of the additional innovations we are doing in the cloud platform. But with this, I'd like to bring the discussion to a close. And thank you very much for your time and attention. Appreciate it.
Thank you very much.